Hey guys, welcome back. So what we're looking at here today is 8.5, functioning with parabolas. So let's go ahead and jump right in. So for this first part, we want to take and determine whether or not the point lies on the graph of the parabola. So we're just plugging in what our x and y values are and seeing if it does indeed work out. So 0 is our y value, 6 is our x value, so we have 0 equals 2 times 6 squared minus 9 times 6 minus 18. So 6 squared is 36, and 2 times 36 is going to take and give us 72. So this is 72 minus 54 minus 18. And if we take 72 minus 54 minus 18, we do indeed get 0. So yes, this point is on the line. So you'll do the same thing for the other three. You'll plug in your points for x and y accordingly, and then simplify to see if it works out. All right, equation of parabola based on the geometric definition. Verify that y minus 1 equals 1/4 x squared is the equation of the parabola in figure 1 by plugging in the 3 points V, C, and E. Show your work for each point. So for V, we're going to have 1 minus 1 equals 1/4 times 0 squared, which is just 0, equals 0. So yes. For C, we'll have 5 minus 1 equals 1/4 times 4 squared, which is 4, equals 1/4 times 16. 1/4 times 16 is 4, equals 4. So yes. And last but not least, E, we have 2 minus 1 times 1/4 times 2 squared. So 1 equals 1/4 times 4. 1/4 times 4 is 1. So 1 equals 1. So they do all work. For 6, if you didn't know that 0, 1 was the vertex of the parabola, could you have found it by just looking at the equation? Explain. Yes, we could have. Add 1 to both sides of the equation. And, to put it in vertex form, not and. To put it in vertex form, 1 equals 1/4 x minus 0 squared plus 1, vertex 0, 1, as we can see from right there. All right. Number 7. So we want to use the diagram in figure 2 to derive the general equation of a parabola based on the geometric function of a parabola, or geometric definition of a parabola. Remember that the definition states that MF equals MQ. So what that means is, so for MF, we're going to take the distance formula. D equals the square root of, well, using what we have, MF here, we have our x minus 0, 0 minus x squared plus p minus y squared. So then, and then for MQ, we have that the distance equals y plus p, because obviously we're going from here to here, so we're just combining our y values that are on the same x value. Therefore, we can set y plus p equal to the square root of 0 minus x squared plus p minus y squared. Now, to get rid of the square root, we're going to square both sides. So we have y plus p squared equals x squared plus y minus or p minus y squared. So then we can FOIL this. So we end up with y squared plus 2py plus p squared equals x squared. We're also going to FOIL this, plus p squared minus 2py plus y squared. Now we'll cancel things out. So we'd subtract the y's, they'll cancel. Subtract the p's, they'll cancel, or p squareds, they'll cancel. So we have 2py equals x squared minus 2py. So add the 2py over. So we end up with 4py equals x squared. Divide by the 4p. And so we end up with y equals 1/4 p x squared. So the a value is 1/4 p. So recall the equation in number 5, y minus 1 equals 1/4 x squared. What is the value of p? The value of p is going to be 1 because we already have that 1/4. Since a equals 1/4, and so 1/4 times 1 would be 1/4. And the p is in the denominator. It's with that 4. And so in general, what is the value of p for any parabola? The distance from the vertex to the focus. Also, focus to directrix. And directrix is your key word for this lesson, directrix. All right, in number 10, all you need to do are figure out what those values would be based on what you have there and what is given. So you're just finding the coordinates for M and R. Now, the next thing we're doing is sketching the graph by finding the vertex and the point M and R, the reflection of M as defined in the diagram above. Use the geometric definition of a parabola and find the equation of these parabolas. So we know our directrix is y equals 9. So it's going to be this up here. The focus is -3, 7. So 1, 2, 3, 4, 5, 6, 7. Yes. Okay, I'm going to make that bigger. It's hard to see. All right, so we know our directrix. We know this. What we need to figure out is where the vertex is. Well, just like before, directrix is 2 from the focus. So right in between is going to be where our vertex is. So it'll be at the point -3, 8. And so then for finding our other point, using what we found, so taking finding that distance there, it's going to be 3 down here. 1, 2, 2 is right there. And there would be our curve. There would be our curve. Kind of, sort of. I know my curve's a little wonky. Now, for the equation, we're going to have y equals, now it's facing downward, so it's -1/4. Now, do we multiply 1/4 by anything, or the 4 by anything? No, because it's just 1 for our p value, and then x plus 3 squared plus 8. That should be a plus 8, not minus 18. All right, so same idea for the others. You're taking and finding your vertex after you draw your directrix and focus and writing the equation for it. And then once you have that, then finding the other 2 points is really, really easy. So same thing for those. All right, the last part, finding the minimum and minimum values for quadratics. So find the maximum or minimum value of the quadratic, indicate which it is. So we have x squared plus 6x minus 5. We want to find out what the vertex is. So that's what we need to know, is what the vertex of this function is. And so finding that, we look for where is the changing point. I want to get this into vertex form. That'll help us find what that value is. We know this is going to be a minimum because it's not negative. If there would have been a negative on our x squared, then it would be a maximum. And so for finding this, we group these together. We take 6 and divide it by 2 to get 3. 3 squared equals 9. So we have y equals x plus 3 squared minus 5 minus 9. 5 minus 9 is 14, so we end up with x plus 3 squared minus 14. So the minimum value equals negative 14 at x equals negative 3. This is the minimum value, and this is where it occurs. And remember, we always flip the sign because it's inside those parentheses. So same idea as what you'll do on the others here in this one. When we group these, we can take a 3 out. So we have y equals 3 times x squared minus 4x plus 8. Take the negative 4, divide it by 2. We get negative 2. We square it. We get 4 plus 4 minus 3 times 4. So we have y equals 3 times x minus 2 squared. 3 times 4 is 12, so we have 8 minus 12, which is going to give us a negative 4. So there's our value. There's where it occurs. Minimum, negative 4 at x equals 2. So same idea for the last 4, just taking and switching it to vertex form to find that minimum or maximum value. All right, if you guys have any questions, feel free to ask. Have a wonderful day.